Yo, this is Zist. MassEntity has pause and resume functionality built in, and I've added some time dilation to that as well for this example. Here the player pawn is represented by the green Quinn, and these blue manis are all mass entities that are represented by mass movable actors. And you can see up here we have the controls. If I slow this down, the manis go really slow, but Quinn is still walking around at normal real-time speed. I can also speed this way up, and the manis are going super fast, and Quinn still is going at normal speed. And I can pause this simulation as well, and you can see the manis are paused. They're doing their little idle animation at 8 times speed, so they're moving around quite a lot, but Quinn again is unaffected. So whether the game is played or paused, regardless of how fast mass is running, the player character, the inputs, the widgets are all moving at real time. Something to notice here is that the time is simulation time elapsed. So right now it's ticking at 1 second per second because we're running at 1x speed. If I slow this way down, now the simulation time is going much more slowly. And if I speed it way up, now the simulation time is going much more quickly. The ticks are always moving at the same speed because this is game ticks. So the game itself is moving at 60 FPS always. The the delta time that's being reported to the game is changing because we're using global time dilation. And so this delta time, the dilated delta time, is what's being applied to the simulation time. If I pause the game, then the simulation delta time is 0, even though clearly the game is still running, but the mass simulation is not running when it's paused. So we have 0 delta time, there's no ticking in the mass simulation, and time is not moving in the mass simulation at all. So the game is moving, player can do stuff, but the mass simulation is paused until we resume. So in the game project here, you'll see I have the mass spawner selected in the level outliner. And then down here, I'm just spawning 50 of these MEC Wanderer data assets. And I'm using a zone graph spawn point generator, and I'm just putting them on the default zone graph tag. Here's the zone graph. I don't know if you can see that very well. Let's see, maybe I'll turn off the plane visibility. There you go. Now you can see the zone graph that's laid out. It's just a very simple zone graph setup. The data asset for the mass spawner, this MEC Wanderer, is right here. And if I mouse over this, you can see this is just a mass entity config asset. We can open that up and take a look at the traits here. We're using a mass movable visualization trait, and the high-res template actor is set to BP Wanderer. I haven't configured anything else as far as that concerned. There's also a state tree trait here, which is pointed at this ST Wanderer. And there's zone navigation just telling it, hey, wander around the default lane. So the state tree, we'll take a look at that. This is really simple. It only has one node, or it has one state, this wander state here, which tells it run some tasks. We're going to run the ZG find wanderer target, which is looking at the default tags, and then we're going to follow path, and then when we're done with that, we're going to go back around. So basically, find a target, walk to that target, loop back around, find another target, walk to that target, rinse, repeat forever. It's a very simple state tree. The animation blueprint is really simple. There is a single state machine. This has a couple of different states. It's getting blueprint thread safe animation updates. This simulation paused is a C++ function that's being run. So is the simulation paused or playing? We set a variable. What is the current sim time dilation, which means how fast is the sim running. We set the simulation speed. So here are the two variables then that we're going to use in our animation graph. When we're playing, if it, sorry, oh yeah, this is the one. If it's not playing, then it's paused. We move to the pause state. When it is playing again, we move back to the playing state. If the simulation speed exceeds 4, we move to super speed. If it's less than 4, we move back here. And again, we can move paused. So this is a very, very simple thing. When we're playing, all it's doing is walking forward. When we're in super speed, all it's doing is running forward. You probably don't want to run forward. I mean, it looks ridiculous, but I just did that to show that you can get data from the simulation here, and then you can use that in the animation graph. The manis are all this BP Wanderer class. That's the visualization class. So this is a character. There's no real setup here. It is configured to use the animation class blueprint that I configured there. And I changed some colors, but otherwise that's nothing really changed there. There is a mass agent component that I've added to this, and we're going to look in just the modified properties. So I added this capsule component collision sync, and I told it sync transform, and so that's what's letting Manny move around as mass is doing stuff. Everything else is pretty much default, other than we set up Manny, and yeah, that's literally the only change, is that we added this mass agent component. The MTG character is the Quinn, the green Quinn that the player controls. And there's not a lot of stuff here. However, there is some stuff related to time dilation. So because we are globally dilating the game, that would slow down Quinn, and she would move just as slowly as all the manis do when we speed it down, or she would move at super speed when we speed it up, and we don't want that to happen. So we're calling into this MTG sim time subsystem method on time dilation changed. And every time time dilation changes, we just change the custom time dilation of the MTG character to be whatever the sim time tells us is the appropriate real-time dilation factor. So that's pretty much it. So in order to get this, in begin play, we get the MTG SimTime subsystem. We initialize custom time dilation based on whatever the real-time dilation should be. And then we register here to the on-time dilation changed event. And we have that called this native on SimTime dilation changed. Then in the in play, we just undo that, get the MTG SimTime subsystem, and remove everything from this character from the on-time dilation changed event. The MTG player controller is the main player controller for this project. So this is what the player's inputs are going into. This is copied from the third-person top-down template from Unreal 5.5, so there's a lot of code in here from that, especially like dealing with this Niagara FX cursor and plugging in an input mapping context. So I haven't changed any of that, but what I have done is I've added some new input actions. I added the toggle play pause action, the increase sim speed action, and the decrease sim speed action. I've also added this set of Niagara components, which are all the Niagara components that we've spawned recently, and I'll show you why that's necessary. If we go and take a look here in the constructor, nothing really interesting there. In begin play, one of the things we're doing is, first of all, we're making sure that we have the sim time subsystem because this is vital to this project. Secondly, we're spawning whatever widget class that you've configured in the blueprint as being the sim control widget class. We spawn that right here, and we add it to the viewport, and then we just remember, which widget it is. Later in play, we then remove that widget from the viewport. So what is that widget? It is this widget here on the top right that has the pause, the play, decrease time, increase time, all this stuff. This is the widget that then is being spawned here and deleted here. We are doing some on-tick work. We'll come back to that. Setup input component. Again, this is very similar to what's in the default project, except I've added these three here. Here we made a change. So this is where there's a mouse down or a touch down event, and it's saying, how long have you been holding your finger down, basically. And this was subject to the global time dilation, which was not working the way that we wanted. So what we've had to do is come and take whatever the world delta seconds is and convert that to real time. And so anytime our player is giving us input, we want that to be in real time. We don't want it to be in globally dilated time. That was an easy change there. Here's another change. When you pick up the mouse, when you release the mouse button, or when you pick your finger up, it says, hey, was your finger down for less than some short period of time? If so, we're going to do some stuff. The main thing that we're doing is we're spawning this Niagara FX component. Well, the Niagara FX component is time dilated, and so that was not good. What that means is when the game was playing real slow and I click on the screen 10 times, there would be 10 Niagara subsystems that were all playing very, very slowly, or if it was going at 8x speed, they would play so fast you couldn't see them. So to make the Niagara FX play at real time, we had to make some changes. We force it into solo mode and we pause it immediately so it's not trying to tick itself. And then we add it to this spawned FX component set. And so that part is pretty easy. But then what we do is when we're ticking, we have to manually tick all of these components. So here it just says, if we have spawned FX components, what's the real time that has elapsed? So the real delta seconds that have elapsed, not the dilated time. And then this just basically goes through all of the spawned FX components that are here and says, unpause it, play 1 frame worth of data at however many real-time seconds elapsed, and then pause it again, and it just loops through here. And what happens is the Niagara component, when it reaches the end of its lifetime, it will be deleted. And when that happens, this will fail, which will drop us down here and we remove it from the list. So I added this debug MTG Niagara systems, which you can enable here at the very top to set this to true right here if you want to debug what's happening with the Niagara systems. But the long story short is this allows us to tick Niagara systems at real time rather than at dilated time, and that's what we want. Nothing else really interesting down here except here's the input for toggle play pause, increase sim speed and decrease sim speed. All we're doing is calling the same methods in the sim time subsystem. So when you hit the play pause, we tell sim time subsystem to do that, or when you try and increase speed, we say do that, or decrease speed, do that. The MTG sim time subsystem is really the core of this project. This hooks into the mass simulation subsystem, which actually handles the play and pause states. And then this adds on to that the time dilation capabilities. So this is a tickable world subsystem because we do need to tick. And it has a couple of events that you can get. It has on simulation paused, on simulation resumed, and on time dilation changed. Now notice that the mass simulation subsystem also has pause and resume events. So you could plug into those, but I thought it would kind of not great to have to hook into multiple subsystems and check multiple different events. And so essentially I'm just rebroadcasting these here to make it easy on application code. You only have to use this MTG SimTime subsystem. You don't have to necessarily know what this is responsible for versus what the mass simulation subsystem is responsible for. Going through here then, we have some nice methods. Get real-time seconds. So this takes some time in seconds and converts it to real time. Get real-time dilation gives you the factor by which this method multiplies. So 1 over get sim time dilation. And anytime you see divided by a number, your alarm bell should be going off saying, what about divide by 0? Well, this get sim time dilation will never be 0. It is always enforced to be greater than 0. At the smallest it will be is UE small number. It will never be less than that amount. So you don't have to worry about divide by 0 here. There's also is paused. There's get sim delta time. So this is the delta time that's being reported to the mass subsystem when it's ticking. There's get sim tick number. So this is how many ticks have gone by in mass that are not paused. So this does not count paused ticks. Get sim time elapsed is the sum of all the sim delta times during non-paused ticks. Get sim time dilation is the current time dilation factor. Can increase sim speed tells you can we make the sim go faster or can we not, and can decrease is the opposite. And this increase sim speed and decrease sim speed are methods that try to do just that, but they might fail, so they will tell you if they are unsuccessful. And then play pause again might fail. This actually uses mass simulation system under the hood. So the MTG SimTime subsystem doesn't really control the play pause state. Mass simulation subsystem does. But here we are coordinating with the mass simulation subsystem to affect player pauses when you want. Now we're down to some data. The sim speed options are basically when you click plus and minus, you know, what are the speeds that are available there. We have some other related data, but this one's important. This you can control in the config, so let's go ahead and open that up. In the default MTG INI, you can set up here what are the sim speed options that you want to be available. So you'll see these are all the numbers when we're going plus or minus that are being used in the game. The MTG Sim Control widget is, again, this one that's at the top of the screen right here. And so this widget is a user widget. It's also a tickable game object, and I'll show you why. So we're setting the widget update interval to be 0.05 seconds. And then basically when we're in game time, when it's not design time, we're connecting all of our buttons. And we're also connecting into the MTG Sim Time subsystem. We're registering for the simulation pause, simulation resume, and the on time dilation events. And so we are hooking in these callbacks. And then on destruct, we disconnect our buttons and we disconnect from the Sim Time subsystem as well. We have a button that updates the pause state, and so here there's some text strings. These are localized text strings, so you can change it for different languages or change it to say whatever you want when the game is paused or when it's resumed. There's also a method to update the time dilation state, which sets the text for the speed. And then for the speed down and the speed up buttons, it sets whether they're enabled or disabled. There's another one for the time state, which again updates the tick number, the elapsed time, and the delta time text fields. When we get the simulation pause state event, we do some shit. When we get the time dilation event, we do some shit. Button presses, we just call into the SimTime subsystem and say, hey, toggle play pause or decrease speed or increase speed. And we are ticking this widget. The reason is because we don't necessarily want to update it every single frame. However, we also don't want our updates to be time dilated. And so the only way that we can do that is to tick every frame, find out the real-time seconds that's elapsed, and only once it's been long enough, then we go ahead and update the widget. So most of the time this tick does nothing, but every widget update interval real-time seconds, we go ahead and update the widget time state. So this gives us consistent updates of the widget regardless of how fast or slow the sim is ticking. If this video doesn't suck, please consider liking, subscribing, share it with someone who's interested in mass. Thanks. Have a nice day.